All right, Demoiselle theorem, section 4.5. So what we've learned so far is a little bit about complex numbers, what their trigonometric forms are, and then how to multiply two complex numbers together and how to divide two complex numbers. Now we're going to move into raising them to powers and taking roots on them. So square roots, cube roots, fifth roots, ninth roots. We're going to learn it all. But at first, we're going to deal with how we raise them to a power, and that's called Demoiselle theorem. Let's go to it. So already written down, I have the trigonometric form of complex number for any number. So z is equal to r times the quantity of cosine of theta plus I sine of theta. All right. Now this isn't necessarily a proof. Actually, it's not a proof at all, but it'll show the point. So what happens if we want to square this? Let's just square this whole thing up. You know what I mean? We want to square it. Well, I don't know why I put that in there. What am I doing? What am I doing? What's going on here? Okay, there we go. And now we're going to square it. Cool. When we square something, that means write it twice and multiply the two things together. So that's what we're going to do. So that's z squared. Well, that's going to equal to, and we say it's r times cosine of theta plus I sine of theta times r times cosine of theta plus I sine of theta. Right? I wrote it twice with a multiplication in between. So let's just do it. R times r. Isn't that r squared? I'm pretty sure that's r squared, right? When you take r times r, you do too. You know that. So that's r squared. Oh, so it looks like the radius, whatever you're going to do to the whole function, you're going to do to the radius. Square it. Next, we need to multiply cosine of theta plus I sine of theta by itself. And we learned in previous sections that when you want to multiply two things together, you just take the angle and you add it to the other angle. So theta plus theta. Theta plus theta. Wait a second, doesn't that make two thetas? I think that's two thetas, and it's going to work for both. Oh, shoot, there we go. So it looks, just on the first one, it looks like we just take our radius and we square it, and then whatever the angle is, we'll just multiply it by 2 when we square. Oh, well, let's see what happens when we do z cubed. And I'm not going to make you watch me write the whole thing out. But basically how it's going to work is you're going to get the radius cubed. And now instead of doubling our angles, we're going to triple them, right? If you had 3 things, you take all the angles, the theta plus the theta plus the theta for 3 thetas. Now, if you were to continue doing this on forever down to the nth root, the nth, that's just any positive integer, whole number, positive, we're going to get r raised to whatever that power is. So whatever you're going to do whatever you do to the function, you're going to do to the radius. If you're squaring it, it'll be squared. If it's cubed, it'll be cubed. But then inside the arguments of our trig functions, we're just going to be multiplying our angle by whatever the power is. And there it is. There's Demoiselle theorem. Old Demoiselle. There we go. So here's what we have from our textbook. There's all written out. Demoiselle theorem. If z is equal to r times the quantity of cosine theta plus I sine of theta is a complex number and n is a positive integer, then we have our formula. Z to the n is equal to r to the n times the quantity of cosine of n theta plus I sine of n theta. But please be aware that this is also a valid formula for it. Sometimes we want to use that over others. Okay. Well, doesn't seem like there's too much going on here. We'll get some example problems. We'll run through these. So there's more to come, and we're not to our roots yet. Just be warned, the roots are going to be the tougher thing. I hate getting punny, but the more complex. So I'll see you in the next one.